Hello, we are going to look at finding the median of group data. And I'm actually working with number 15 out of section 11.2 of our textbook. So it's part of the homework problems and wanted to take time to explain this concept. What our definition tells us is that we want to look at the histogram and we want to look at the area. So I have a set of data. The first thing I want to do is draw the histogram so that I have a picture for it. So a histogram is basically like a bar graph. So I have categories 1, 2, 3, 4, and 5, and I'm just going to use those to number my bars because I have the intervals right here. So category 1, 2, 3, 4, and 5. And then I need a scale that's going to include all of my frequency information. So it looks like I have to go up to 23. So go by 5, 10, 15, 20, 25. That should work. So I will redo this then using technology so that you see a good picture, but truly just a sketch will work. You do not have to use technology to make a beautiful histogram to do these problems. So then what a histogram is it like a bar chart, but the columns actually touch. So column 1 is just going up to 3, and then column 2 goes up to 11. Column 3 goes up to 23. Column 4 goes up to 12. My columns aren't very even here, sorry about that. And column 5 really short down here at 1. So all of these bars together make a polygon shape. So you can sort of see my cursor here tracing it out. A polygon is just a many-sided figure. And so the area of this is what we want to split in half. Now if we look on the left-hand side, we know the height here of this rectangle is the frequency, which was 3, and here it would be 11. So 3 plus 11, that's a total of 14. Sort of balanced out over here, but not exactly, because the height of this one is 12 and the height of this one is 1. 12 plus 1 is only 13. So you can see there's more data here than here. So to split the data in half, we'd come down through this middle bar, but we're not going to come exactly in the center because the left and the right aren't identical. They're not symmetrical. So in finding the median, what we're going to do is find the data point along this bottom edge, which is truly these class intervals, the data point that splits it so that the area on the left equals the area on the right. So now I'm going to switch to a technology drawn graph so that you see a more accurate picture, but as I said, you can figure it out with just a hand-drawn sketch of the picture. It gives you enough details to calculate the group median. So my picture now is a little bit better because I used Minitab, a software program, to create the picture, and it's better labeled. So you see my class intervals along the bottom. This is the frequency, and you see a title here, and that title is coming from question number 15 of section 11.2 of our textbook. In order to calculate the areas, I have to know the area formula for a rectangle. So the area of a rectangle is length times width. And when I look at each individual rectangle, I'm going to be able to figure out the length and the width. So the length, which I'm using sort of as the height, is just the frequency. So this first rectangle would have a length of 3, the next one 11, the next one 23, and so forth. The class width I'm going to have to calculate by looking at the different classes. And the great thing is, as long as we set up our class intervals correctly, the class width is a constant. So if I take 899.5, subtract 799.5, I see that the class width is going to be 100. Same thing for the next class. So what I'm really doing is just using this formula. I'm taking the upper value of my class minus the lower value, and in every single interval that is 100. So this particular frequency table has been set up well. It should always be a constant number. So now what I'm going to do is to calculate one rectangle at a time. And by doing that, I know already that the middle line, the median piece of data is here somewhere in here. So I really have to only calculate the area of the rectangles on this side to figure out the median, but I first have to know what is the overall area, because the median is the halfway point, so I have to know the total. So let's take a look at how we would do that. So our first rectangle, we said that it had a frequency of 3. We said that the bottom edge here, so that 3 is really the height right over here, the bottom edge is 100. So the area of this particular rectangle is 3 times 100. Same idea here. So the height of this rectangle is the frequency. The height here is 11. The class width, which is the base of the rectangle, or the width of the rectangle, is again 100 because we can subtract. And so the area is 11 times 100. Same idea for this next one. So the height of the rectangle, the frequency is 23. And the width of the rectangle is 100. And we multiply those two together to get the area. Same thing here. So height here is 12. Width is 100, multiply to get the area. Same thing here, height is 1, width is 100, multiply to get the area. So 300 plus 1100 plus 2300 plus 1200 plus 100. So the total of all of those is 5000 or 5000. Now the median is going to be at the middle of that. So if I get the middle of that, I'm going to divide that by 2. And so my median is when the area is exactly 2500 or 2500 on each side. So we said that middle line is going to fall in this interval and not exactly on center because my left and my right sides are not symmetrical, but somewhere close to that center. So now we're going to look at figuring out the area for just the half that we want. So I'm going to be working from the left. On the left-hand side, this first rectangle had an area of 300. My second rectangle I know is included in the half, and it had an area of 11 times 100 or 1100. My third rectangle, I don't want the whole thing. So what I do want, the length of the rectangle, the height of the rectangle is fixed at 23. So to find the area, 23 times. Now, to figure out the class width, we have that the class width, not sure how this goes away here, but class width is the upper value minus the lower value. Well, I know the lower value of the class, 999.5, but because I don't want the entire rectangle, I don't want the whole class, so I only want part of it. So I want my upper value to be my median. So I'm going to use M for median minus the lower value of the class, the 999.5. And the sum of these guys, first rectangle, second rectangle, and this rectangle, which we don't know how much of, that's why we have the variable, is going to be equal to exactly half the area. So the 2,500 as half the area. Now, in order to solve this, first thing I need to do is combine like terms here. So on this side, these two together would be 1,400 plus 23. I'm not going to distribute this because it's going to end up being more work to solve if I take the time to distribute. 999.5 is equal to 2,500. So I can subtract 1400 from both the left and the right. So when I subtract 1400 on the left, cancels. 2500 minus 1400 is 1100. So moving over here to continue solving, I now have 23, that's the height of that rectangle, times m minus 999.5 is equal to, and so right over here I took 2500 minus 1400, so I have now 1100 as that answer. I want to continue by dividing by 23 on both sides of my equation. And just doing that with my calculator, so what I have left here is I have the m minus the 999.5 is equal to, and on my calculator I got for that about 47.83, and that didn't come out exact, so I just rounded. And then finally, to solve, I add the 999.5 to both sides of my equation, and I get my median value, so m is equal to, so I'm adding 47.83 plus 999.5, and I get 1047.33, and that is my median value. So we can see 1049.5 would be right here in the middle, but we're not going to quite go to the middle, so we would be over here a little bit. Right about here is the line for the 1047.33 in our data. And at that line, the left half of this polygon is exactly equal to the right half. So we've split the area exactly in half, and that means that we have found our median. So key concepts in this is that we're looking for exactly half the area. We find the area of each rectangle using the area equals the frequency times the class width. And we find the class width by subtracting the upper and lower values, which is why right here in our formula, the median minus that lower value allows us to go ahead and solve for the median. When we're solving for the median, we used exactly half the area. We used the area of two of the rectangles, and we split the third rectangle in half. So I hope that is helpful to you as you look to solve grouped median problems.